All right, so since we've all been to vector land before, let's write down the vector properties list. And really, there shouldn't be anything super surprising on here, right? Let's see. First things first, I think we know that a vector A plus a vector B is, yes, commutative. So B plus A. Let's see, what else do we know? I think we probably know that if we add B and...
Yeah, B parentheses.
So we add A and B and C with parentheses like this.
Yeah.
But that's the same thing as...
A plus B in parentheses.
Cool. So this is like associativity, right?
Are we going to lose points for missing vector symbols?
Yeah.
Okay, just checking.
Yeah, vector symbols matter.
Dang.
It really matters what category of object you're talking about, right? Are you talking about a number or a push?
Yeah.
But don't worry, you'll write enough of them in here that it will become pretty obvious which one you mean. So, why would this be true? How about that? Yeah, I mean, you guys have written this down a million times, probably. But why does it work? Like, why doesn't it matter if I add B plus C first and then add A later?
Because if the pushes, we pushed them in different orders and got the same place.
Yeah, it's really that parallelogram thing again. Okay, so let's see, we have those two. What else do we have?
The zero.
Zero times A vector gives us
Okay, so we had this one, right? You add the zero vector, you get
just get A.
get back to A, which is of course the same thing as if you add 0 and A, right?
Yeah.
Okay, and then there's also this one.
By the zero vector, yeah. You get
That just becomes zero.
This is
Zero's
the
just a
zero
vector.
vector.
Oh, that
Right,
one's not
so
on
this
here.
is 0 as a
Oh.
scalar. Oh, that one's not on.
Yeah.
What?
So 0 is a scalar times any vector at all, right? It's going to give you the 0 vector. This one's on there for sure.
Yeah.
What's 1 times the vector?
It just becomes A vector.
That's just the A vector.
A minus A.
Yeah, A plus minus.
Yeah.
A plus a minus A.
Yeah, and why am I writing A plus minus A?
Opposite direction.
Okay, yeah, that should, so this should be a vector A plus the,
Opposite.
yeah, what do I mean to multiply by a -1? I didn't really talk about that in terms of scalar multiplication, did I?
It's the same.
What does that do?
Changes the direction, but the same magnitude.
It should do, yeah, the same magnitude but opposite
Yeah,
direction.
a 180
right?
flip.
Yeah, 180 flip makes sense in 2 dimensions, but less so in 3, right?
Yeah.
I really mean that you interchange the tip and the tail of the vector, right?
Yeah.
Okay, so if I add a vector and its interchange, what am I going to get?
Zero vector.
0. And why aren't I writing A minus A?
Because we know vector addition.
Yeah, I
you
just
not
really
take
didn't
away
tell you what
this?
what subtraction would mean, right? We talked about addition in terms of vectors, but we didn't really talk about subtracting vectors.
You can't really take away force.
Yeah,
Not apply as much.
it doesn't make sense in the same way that I think about, when I think about addition, I think that stuff over there and also this stuff over here, right? That makes sense with pushes. When I think about subtraction, I think like this stuff take away this other stuff, right? That doesn't really make much sense in terms of pushes. It's okay if you want to write this as A minus A, right? But I want you to note that really the thing you're doing is adding negative A. Cool? All right, so what else we got?
Distributive from the left.
Distributive from the left. Wait.
Are you telling me that when you have
Whoa. Giant bug.
A vector times B vector?
Okay, so what do you mean distributive from the left?
I just giving you a cue to your notes.
So you mean that this distributes?
Because C plus A vector.
Okay, but what are the operations happening here? What does this plus sign mean?
A and B. one drawn from the end.
Yeah,
push
but
with
what's
a
this?
push.
Yeah.
Yeah, combining vectors.
Yeah, this is vector addition, right? What's this operation?
Scalar multiplication.
That's scalar multiplication, right? So I'm saying if I do the vector addition first and then multiply by the scalar, right?
It's the same thing if you multiply by
It's the same thing as scaling up each piece and then doing the vector addition. You guys see that? That should make sense in terms of a diagram, right? If I drew some arrows and stretched the whole diagram out, that would be about the same as if I stretched each arrow and then drew the diagram out of the pieces. Cool?
Is it the same as C was a vector? Then we would just do the same thing.
Ah, so if C was a vector,
Then the side matters.
and oh no, this is even worse than the side matters. So if you wrote this down, right, to try to think about this, well, what if C was a vector? Now what do your operations mean? This one's definitely vector addition, right? What's the operation here?
Vector multiplication.
Yeah. Do I know how to multiply vectors?
Not yet.
Not yet.
Not yet.
We're getting there.
Matrix.
Will I actually know how to multiply vectors ever?
Not
Not
until
technically.
linear.
No, definitely not.
No.
So this is a thing. There are some operations with vectors that you guys will get. They're a dot product and a cross product. They're not multiplication. If they were multiplication, right? When you multiply two numbers, what do you get?
Another number.
You get a number, right? It stays in the same space. So when you multiply two vectors together, you would hope to get a vector back out, right? That works in terms of cross products, but it doesn't work in terms of dot products. And then there's some other properties of cross products like that anti-associativity, or sorry, anti-commutativity, that make it also not work as multiplication. So this jazz, it's never going to make sense in R3. There's only one place where this kind of thing makes sense, and it's not real numbers. Thanks. All right, what's the other one?
The right side.
On the right side.
You got D plus E. The quantity D plus C times C. Or D vector plus. I'm just.
I know, I'm just screwing with you.
It's like.
Okay, so I've got D plus E times a vector, or wait, these are vectors, right?
Yeah.
Then I'm multiplying by a scalar?
Well, it wouldn't be different.
Yeah, that
That's why
shouldn't be any
linear's
different,
frustrating.
right?
Because you think it would be different.
This really should tell you that it doesn't really matter what side I write scalar multiplication on.
Yeah.
I'm going to go with the idea that scalar multiplication really belongs on the left. So I'm even going to change this to C times D plus C times C. What's up, Rick?
What about A plus C in parentheses and then D vector? Just to put random stuff out there.
That's the next one.
Yes.
So what's the difference between this and the two above?
Okay, that one was actually easier than it looked.
Yeah, this here is addition in the real numbers,
A
right?
constant.
It's scalar addition. And this is scalar multiplication happening. Okay, so I'm going to add two numbers together, and then I'm going to multiply by a vector. What should that give me? Okay, it should give me a vector, right? And that vector should be made of AD plus CD. Yeah.
Can you have like A plus D vector?
A plus D vector.
So like a constant plus a vector?
So,
Wouldn't that just be a vertical shift?
in other words, does something like this make sense?
Seems like that would just be a vertical shift.
No, like the
No, because if it was a vertical shift, and right, this thing here, this scalar here, that's a number in R, right?
Yeah.
This is a number or a vector in like R3. So does it make sense to combine a push and a number through addition? Not really. I just don't have a tool for that. So this guy is, it's a, unfortunately, something that just doesn't make any sense.
how about if you nah, never mind.
Is it the same thing if you wouldn't add real numbers to imaginary numbers because they don't live in the same realm?
It's so close to it, except the real numbers do live in that thing.
No, I'm just going to do it anyways, just to make sure. A plus C with the vector sign over both of them.
Certainly, I can add vectors together, right?
Yeah. Back to
Well-
the first one.
Just wanted to make sure.
Yeah. I can add vectors together. I can add numbers together, right?
No,
It's-
I'm not individual vector signs. Like the vector sign is over the entire thing.
That doesn't. it's not
Talking about
right.
like dividing.
That's okay. That's
like-
reasonable. It's just a bizarre naming convention.
A
So if I
C
did
vector.
A plus B vector,
Just wanted to make sure it's the same as that up there.
yeah, this maybe is a reasonable thing. I would never write this because this is just really a bizarre naming convention, right? You mean the thing A plus B as a vector? And I think the only reasonable thing to mean by this is A plus B as vectors each. This is really just a funny way to name something. I wouldn't write this, and I don't think most people would either. It's not that it doesn't make sense. It's just
Wait, wouldn't the vector change?
so
Like,
unless these are both vectors, right, or both scalars, then adding them together doesn't make a ton of sense. So they have to be the same object, category of object, before I add them together. So if they're both vectors, I can add them together. But then calling the result A plus B vector would be just a weird naming convention. Because I would call it A vector plus B vector.
real.
Maybe this is the confusion, Drake. This thing doesn't turn a number into a vector. This thing tells you the name that you're talking about is a vector. So this thing altogether would tell you that the thing A plus B is a vector. And it wouldn't be unless both A and B were already vectors to start with. Does that make sense?
I was kind of thinking, in my mind for some reason, that we'll put put on the board an A vector connected with a B vector. No, I meant like as in if you were
Oh,
to put it
I
on.
see. So
Push
like,
end to end.
here's a
with
vector
push.
A, here's a vector B.
And then underneath it, put another line that connects A to B at the end. And that's what I was thinking was A plus B vector.
Yeah, so this thing I would call A plus B, both as vector. Right, and if you wanted to rename that thing, I think this would be an extremely bizarre choice.
Alright.
Basically
But
because
the
that...
reason why I was thinking of this is because it's a completely different, how do I put it?
Yeah, it's not a format we have on the board for sure. And the reason I don't have this format is that this thing isn't there to turn something. It doesn't change the object I'm talking about. It's just to remind me what category that thing lives in. Does that
Okay.
make a little sense? Alright. Let's see, what else
Last
did I need?
one.
Last one?
Constant times a constant in parentheses times a vector.
Oh, times.
Okay, so I've got A times B
Times the C vector.
times the C vector. Oh, and now I have lots of dots, right?
We'll just combine them with A, B.
So, yeah, really, I mean,
Yeah.
AB times C, right? But what's that, like, what's this times?
It's just a
That's
number.
just a number.
That's
Yeah, that's
Two
scalar
constants.
multiplication, and this times here?
more scale.
Yeah, that's a scalar times a vector, right?
Yeah.
So, this is real number multiplication, and this is
Vector.
scalar multiplication, right? Like, scalar times a vector. Okay, so, no, you're fine, that's totally ambiguous.
Oh, okay.
Because I would call this scalar multiplication and that scalar multiplication, even though they're actually different. Right? Okay, so this is multiplication of scalars, and this is scalar multiplication. This is a really stupid distinction. What's the result you should get out of it?
A, B, C, vector.
Yeah, it's all the same thing, and I'm sure I have it phrased this way on there, right?
Alright.
If you're going to inflate by A times B, right? You may as well inflate by B first and then inflate by A after, right? Does it make sense that that result would be the same? Yeah.
And the order of that does not matter.
Yeah, and the order of that doesn't matter why.
one of the previous rules. Where was it?
There's C times.
It's actually because scalar
Yeah.
multiplication of scalars, right? Doesn't care about order. Cool. Check done. Properties. What's the result of all this jazz? Basically, everything behaves the way you would normally think it does, right? Except these two things we crossed out, right?
Yeah.
I don't know how to add vectors and scalars, and I don't know what the other one was. Oh, I don't know how to multiply vectors. Cool. So you're only forbidden a couple of things.